Here a practical example of modernizing a traditional software application, non-compatible with emerging technologies, such as cloud, by using the artist solution. Software Limited is a SME managed by John and is specialized in a J2EE e-commerce application, named Petstore. In the current situation, the application is not scalable, is difficult to monitor due to multiple instances, the support to the customer is poor, and then the company is losing market share. Current business model is not helping to keep customers and attract new ones. John wonders how to overcome the current situation and thinks in offering Petstore as a service. Many questions come up to his mind. Artist supports him in answering these questions and in guiding the company towards the final goal. By applying a sequence of steps with their support in tools, Artist will assess the feasibility of the migration of Petstore to the cloud, the modernization of the application to transform it in a software as a service, and to verify the migrated application behaves as before but with enhanced non-functional properties. The MPT is a user guidance tool that covers all artist faces, serving as a single entry point to an exit point from the artist tooling offer. Upon successful installation of the MPT, the Eclipse welcome page will include information about the artist project as well as an end-to-end tutorial. This MPT provided tutorial consists of composite cheat sheets for helping and guiding the user throughout the artist faces and corresponding tools. Each MPT composite cheat sheet offers a group of simple cheat sheets, one for each artist tool or process that is covered by the given artist methodology phase. Step-by-step instructions on how to use each tool are being offered. The MPT also facilitates the immediate connection to other Eclipse-based or web-based artist tools, by automating actions, such as opening wizards, views, dialogues, etc., in order to make the usage of the tools easier and faster. The MPT also customizes the migration and post-migration phases, according to the user's role and the analysis results, obtained during the pre-migration phase, in the form of reports. For this purpose, the MPT offers a web application, where the end user can upload the pre-migration results, and use them to view a customized graphic representation of the artist methodology. The pre-migration results are also seamlessly used to customize the cheat sheets that follow for the migration and post-migration phase. At the end of each phase, the user can automatically progress to the composite cheat sheet for the next phase, which has been customized to fit the project's needs. Previously to the migration decision, John must assess the business and technical feasibility of the migration. So, he needs to know where they are and where they want to arrive. The Artist Maturity Assessment Tool is a web-based tool that analyzes the maturity of a legacy application, in this case the Petstore web application with respect to its migration to a cloud, considering technical, business and process aspects. Maturity Assessment Tool requests information in an structured and clear way under 3 dimensions, technical, business and process, for both the current situation of the application, that is the legacy application, and future situation of the application, once the migration takes place. This information is provided by different roles inside the Petstore company: CTO, business manager, product manager or software developers. The questionnaire is structured in dimensions already described, areas which are thematic concerns, for example business strategy, and sub-areas consisting on the minimum categorization of a certain topic. For instance, under business strategy, the sub-areas could be 1. Creation of the business plan for the new service offerings, and 2. Management of the business plan. MAT is based on questionnaires. The user is asked a question and presented possible answers and occasionally free text to explain the answer or to provide further details. All questions refer to the current and future situation, seeking always to characterize an application as cloud compliant, that is, an application that fulfills all technical, business and process requirements established by the reference standards, such as the ISO CCRA, ITIL, EFQM and TOSCA OASIS. The results of the artist modernization assessment are presented in two ways, on line graphs and punctuation results, which are provided per dimension and area inside the dimension in terms of punctuation obtained versus the optimal punctuation that can be obtained. The more similar the answer is to the standard best practice, the greater punctuation is obtained for a certain dimension or area. Apart from the punctuation figures, the results are also shown to the user in a graphical way. Two different types of graphics are offered to the user, a bar graph, for the areas inside the dimension, and a radar graph, for the dimensions. Other questions are also asked to the user in order to generate special reports for other artist tools. Apart from the graphical information and the figures, a set of reports is generated. End user report. This report is a document that can be stored in PDF form for the Petstore managers and decision makers. That includes all the questions, answers, punctuation and graphics generated during the maturity assessment. Methodology process tool file. The methodology process tool file contains specific information to be used by the methodology process tool for methodology customization. It is an XML file containing the answers of some of the questions performed during the maturity assessment that are useful for materializing the personalization of the artist methodology. Migration goals file. This is a first model of the migration goals. These migration goals are deduced from the user answers, and generated following the artist migration goal modeling language. Now John knows the gap between the current situation and the desirable one, so he can evaluate how difficult will be the process. Before we proceed with the migration of the Petstore application to the cloud, we need to evaluate its technical feasibility. For doing so, we use the Artist Technical Feasibility Tool or TFT, available through its TFT perspective. TFT suggests possible migration strategies that may fulfill the migration goals for Petstore, previously described by the user, using the Maturity Assessment tool. This migration goals model needs to be opened in the Migration Goals view. This view permits the user to enable or disable goals and the selected cloud target. Only enabled goals will be considered in the TFT analysis. The suggested migration strategies can be applied to the Petstore application itself or to some of its components. In order to identify its components, TFT requires to open a Petstore component model, whose components are characterized by stereotypes taken from domain-specific UML profiles, into the TFT inventory view. The inventory view shows the Petstore application and its components, the stereotypes that characterize the components, the main classes owned by the components and the suggested migration strategies. These strategies are suggested by TFT, by mapping technology-specific heuristics to the characteristics of the Petstore components. The user can modify anytime the list of suggested strategies, to be applied to a concrete component, aiming to migrate it to the selected cloud target, by using a dialog that shows the available and selected strategies. The user can modify the migration goals, enabling or disabling any of them. Disabled strategies will not be considered by the TFT heuristics. Therefore, the set of selected strategies would eventually change upon changes on the goals. For instance, disabling the multi-threading or the scalability goals removes the strategies that would materialize such features in the migrated Petstore application. Similarly, the user can change the cloud target, and upon that, TFT will produce a completely new set of suggested migration strategies, targeting the migration of the Petstore towards that new target. Once the user has completed this technical analysis, TFT can compute required relative efforts to accomplish selected strategies, using additional technology-specific heuristics based on expert judgment. For doing so, the user is prompted to provide the source code of the Petstore application, which it is used by TFT to compute different software metrics, such as the maintainability metric, which are used to compute the Petstore component's complexity. This complexity, together with the migration strategy complexity itself, is used to compute the relative efforts. These computed figures are shown to the user in the migration efforts view, for each Petstore component. Additionally, By double-clicking on one component, a detailed breakdown of selected strategies is shown in a pop-up view. In this view, the user can provide a rough estimation of an absolute effort, in person month, for one strategy, and the remaining absolute efforts will be computed as well, using the relative efforts. The completed TFD analysis can be exported in CSV format to the file system. Business feasibility is so important than technical one, so such analysis is now performed. The artist cost-benefit analysis is a conceptual framework that provides a way of calculating and comparing benefits and costs of a project, investment or even government policies. With the help of the artist cost-benefit analysis tool, the Petstore CEO will be able to 1. Determine if the investment to be made is feasible and justifiable, and 2. Provide means to compare investments or decisions. In the case of the migration of Petstore to the cloud, the comparison would be between migrating totally, partially or developing from scratch, with the main purpose of analyzing whether the benefits outweigh the costs and by how much. The starting point of this CBA tool is the acquisition of certain baseline data. This baseline data is completed by means of interviews with relevant stakeholders, Petstore CEO, CTO, etc. The data gathered mainly include tangible expected benefits, one-time costs and recurring costs. Once this data is gathered, a break-even analysis is performed. In this case, the break-even analysis consists on a comparison of the costs of the proposed migrated system against the costs of the current system. Based on the same data and in parallel, without user intervention, a payback analysis is performed. The aim of this payback analysis is to provide the user with an estimation of when the company will recover the investment, taking into consideration the net benefits and costs and the cumulative benefits and costs. Another economic value included in this CBA is the present value, and it shows the value as of today of the investment of migrating the software system with a discount rate of 5%. The final economic indicator provided to the user is an overview of all the previous data, showing him the net present value of costs, of benefits and the cumulative difference. The discount rate remains 5%. After the feasibility analysis, John will take the decision, and if he decides to go ahead with the migration, a deeper analysis of the application is required. In order to obtain models representing the software artifacts from the original system, we apply a reverse engineering process composed of 2 steps, which we call model discovery and model understanding. We will focus now on the model discovery step, where the required initial low-level models are extracted from the existing software artifacts. This step is a 2-phased process. First, we analyze the source code to obtain models at the same level of abstraction. Then these models are transformed into more abstract models. We will show now how we apply the model discovery step in the Petstore scenario. For the Petstore scenario, we first discover models from the Java source files of the project. These initial models mirror the structure of the source code and allow us to have a one-to-one representation of the code as model, thus acting as entry point at the modeling realm. In this video, we show the Java Model Discoverer integrated in Artist. The Java Model Discoverer is integrated in Eclipse as a plugin and can be launched for a particular project by clicking on the corresponding contextual menu entry, as we show. The Discoverer can be configured, for instance, to specify the level of detail of the discovery process, the use of incrementality when discovering, or, as it is done in this case, to specify that the discovered models has to be serialized into a file due to we will use it afterwards. Once the model discovery process has finished, a new model representing the Java source files of the project is generated. This model mimics the very same structure of the project source code. No further data or content analysis is realized at this step. Given this model, we can easily navigate through its contents and have a general view of the software system. For instance, in the video we show the class named BlueFilter. As can be seen, the element class declaration and its subelements constructor and method declarations are included in the model representing the source code of the class. This model element includes all the very same information that can be found in the source code, such as the constructor, its methods, superclasses, etc. As we will see afterwards, this low-level model will allow us to obtain more abstract information by means of model-driven techniques. We use now the Java to UML class model discoverer to obtain UML class models out of the previous Java models. This model provides a structural view of the software system, thus facilitating the understanding of the software system and, maybe more importantly, enabling a more informed execution of the rest of the process. As we already have Java models now, we can use model transformations to obtain UML class models. The Java to UML class model discoverer is also integrated as an Eclipse plugin and is executed using the Java model obtained previously as input. As before, the UML class model discoverer can also be configured. In this case, we also set that the resulting discovered model has to be serialized into a file. Once the model discovery process has finished, a new UML class model is created. Being a structural description of the project source code, this model will enable a better understanding of the project both for developers and for the remainder of the artist process. For instance, in the video we show the class declaration representing the class default controller action. The information in the Java model has been analyzed and transformed in order to be represented as a UML class diagram. For instance, class declarations are transformed into classes in UML or method declarations are transformed into operations in UML. We show now the UML activity model discoverer. In contrast to the UML class models, which provided a structural view of the software system, the UML activity models provides a behavioral view, which gives more insights about the software system and is also used in the rest of the process. In a similar way as we explained before, once we have Java models, we can apply model transformations to obtain other suitable models like UML activity ones. The Java UML activity model discoverer is also integrated in Eclipse as a plugin and takes the Java models obtained previous as input. As before, we configure the discoverer to serialize the discoverer model into a file. The result of the discovery process is a UML activity model, which includes details about the behavior of the system such as the statements of the class methods. For instance, in the video we show the class simple capture. As can be seen, field declarations are transformed into properties, and method declarations into activities in the Java activities model. Additionally, the content of the methods, that is, their statements, are transformed into activities. These activities represent at a language-agnostic level the behavior of the methods, using UML standard elements such as flow or nodes. The combination of the discovered models are later used in the model understanding phase, where the previous models are digested to obtain models at a level of abstraction suitable for the next steps of the artist process. Component Model Generator tool is included as part of the Model Discovery toolbox of the Artist Suite. It enables the extraction of UML component models from UML structured class models, such as the one shown in the demo, which corresponds to the Oracle Petstore application. The modeler can use it by right-clicking a class model in the Eclipse workspace, and selecting the menu entry, Generate a Component Model. There are several generators available for different technologies. In this example, we select the J2EE generator. After few seconds, a component model has been generated. This model contains several candidate components detected by the role they play in the underlying technology. It searches for traces of this technology in the class model, by applying search-based model querying techniques. In this example, this technology is Java Enterprise Edition, and the detected components are constituted by classes that play a concrete role within the J2EE framework. The jump tool facilitates to automatically generate stereotypes from declared annotation types and to apply them in the context of a reverse engineering scenario. Thus, it allows developers to jump from Java to UML, thereby exploiting UML profiles to also capture Java annotations at the UML level. We use the jump tool to generate the JPA profile. For this, we execute the jump tool on the source code of the JPA. To this end, we create a new run configuration and run it. The JUMP tool generates standard compliant UML profiles, so any UML tool can be used to visualize it. We use Papyrus to visualize the generated entity stereotype. We can see that it extends the UML metaclass type, which generally corresponds to type in Java. The added constraint restricts the stereotype application to exactly those elements that are targeted by the entity declaration of the JPA. To allow developers to access profiles without generating them again and again, the idea is to collect them in what is called the UML Profiles Store. Technically speaking, the UML Profiles Store is a plugin that exploits extension points. In this way, developers can directly use profiles in Eclipse tools. To sum up, the JUMP tool precisely defines extensions, uses signatures accordingly, and completely captures features. Now we want to execute the JUMP tool on the reverse engineering phase of the Petstore in order to apply profiles at the level of platform-specific models. For this, we run the prepared lunch configuration. Several profiles have been applied in this reverse-engineered scenario. If user-defined annotation types are declared in the application code, the necessary profile is generated as well by JUMP. We can see, for instance, that the JPA profile that we have obtained before with JUMP is included in the model. All other profiles used in this scenario are provided by the UML Profile Store, such as the JDK7 profile. Let us navigate to the order class of the Petstore to explore the generated result in more detail. As we can see, the reverse-engineered order class in the UML model captures the annotations applied to the application code in terms of stereotypes. With the slicing based on annotations, we manage to obtain a view of the model only with the elements that satisfy certain properties along with the proper set of associations. Let us execute the slicing transformation on the generated class diagram. The idea is to set the focus only on the persistable elements, which in our example are stereotyped with the JPA profile. For instance, the entity and embeddable stereotypes. Applied stereotypes facilitate also to improve the quality of the generated slice. For instance, several plain associations in the generated slice are in fact composition relationships. They can be inferred by considering the stereotypes of the member classes. One rule in the last transformation that we execute produces a composition relationship if the member classes are annotated with the entity and embeddable stereotypes. Having the completed models from Petstore application, several transformations can be applied to the original code to inject all the cloud patterns to make it compatible and effective in the cloud. Several tools are related in this process. In the forward engineering process, it takes place the evaluation of the migration success in terms of functional and non-functional requirements. Whereas functional behavior equivalence is an implicit requirement of the migration which is evaluated by means of test cases and end-user-based testing, non-functional requirements need to be stated explicitly in terms of goals. The central artifact in this iterative process is the migration goal model which guides the optimization process towards the cloud. The goal model captures the migration objectives that should be achieved by the migration to the cloud in a structured way. The initial version of this goal model is created by analyzing the questionnaire filled out during the maturity assessment and can be adapted by the user with further detail. To support the user in this adaptation, Artist provides a fully fledged textual editor. Broadly speaking, goals are specified upon well-defined catalogs of properties. These properties are applied in the context of the actual software application. Here, we apply the programming language on the whole application. Based on these applied properties, we can formulate goal conditions. For example, that a predefined programming language or a specific cloud provider should be used. The goal priority reflects the importance of the goal. Now let us assume we are interested in the average response time of the application. So first, we apply the property in the context of our application. As some properties cannot be evaluated in all possible scenarios, we specify a dedicated workload scenario under which the property should hold. Such a scenario is defined with a dedicated workload pattern and are FUML activity diagrams. FUML is a executable subset of UML. After applying the property, we can define our goal. In general, we distinguish between soft goals and hard goals. Soft goals are defined upon high-level properties which cannot be quantified directly. Hard goals are defined upon more low-level, quantifiable properties. Typically, a soft goal can be broken down into one or more hard goals. Furthermore, goals can be structured in a hierarchical way. Here, we specify that we want the response time to be less than 1.5 seconds. We do this by reusing defined types of the MART library, for example the duration. To adapt the application to fulfill our goals, we use so-called cloud optimization patterns. These patterns are defined in pattern catalogs containing information about each pattern and the relations among the patterns. In praxis, these patterns are realized using model transformation techniques. Having the software application, the goals as well as the knowledge about possible patterns, we can start to explore the migration design space with our iterative process. A simple run dialog can trigger this exploration. After the goals are analyzed, we apply search-based software engineering techniques such as genetic algorithms to explore the possibly infinite design space of optimization patterns. The resulting sequences of optimization patterns are then further analyzed using model-level simulation and analysis techniques. The best of these results is applied and a user-friendly format of the migration evaluation is produced. This contains first the measurements that have been taken during the simulation and analysis in a structured format. That format is very close to what the user already knows from the goal modeling. Second, we have an evaluation of all goals based on those measurements. We can see the applied optimization patterns, the evaluated properties that have been applied, and the result of the evaluated goal conditions. In this example, all necessary goals have been fulfilled to determine that the migration can be considered a success. To improve the understandability of the results for the user, some measurements are also visualized graphically, for example, the evolution of the throughput of all the service classes, then several graphs that have been produced based on these measurements, and of course the final evaluation of the goals, where we can see which goals have been fulfilled or not based on what measurements and whether the complete migration can be seen as successful. The following video shows the application of one of the optimization patterns, namely the key value storage pattern, through Objectify. In this way, we aim to change the architecture of the database by converting a relational schema into a key value storage. In the first place, we apply the pattern in a model level. The model that we take as input is the data model shown before and that was produced by the slicing. Afterwards, we apply our code generator to produce Java code that includes this pattern. We use the Objectify framework for the persistable entities. For this reason, we first apply the Objectify profile and stereotypes by means of a model-to-model transformation. Then, we generate the code for the Petstore application specific for the Objectify framework. For this, we launch our code generator, which extends the UML to Java core code generator developed by Abia. We can have a look for instance at the purchase order class that has been generated along with all its methods. There we can also see the specific annotations of Objectify, such as the entity annotation. The code generator also obtains the service classes that contains the behavior needed to deal with the persisted entities, such as create an entity, update an entity, remove an entity, etc. The reusability trace tool is an application integrated in the Eclipse environment that permits to select pieces of code that could be directly reused from a project to be migrated depending on a set of technological conditions. This tool will be used in the scope of the modernization of the Petstore application, by selecting and injecting that reusable code, after the reverse and forward engineering take place. The reusability criteria are established by combining the information already inserted through the maturity assessment tool and a set of rules specified at a configuration file. Default reusability conditions can be changed by the user. Once the final conditions have been established, the user can see which methods are considered reusable by the system. The user is free to change this automatic proposal, according to his knowledge of the application. After the definitive selection is done, the modernized application is generated in the specified target folder, taking into account the reutilization rules. It goes a step further after the forward engineering process, by injecting directly the reusable code and commenting the non-reusable one. This way, the developers will know quickly where to make the needed adaptations. Deployment descriptors for specific cloud target platforms can be generated from deployment models, using the deployment tool. In our particular migration project for Petstore, we select the Google App Engine as cloud target. Using Artist, modelers can design deployment models using the Cloud ML at Artist and the Cloud Application Modeling Language, namely, CAML. CAML-based deployment models are UML deployment models that use specific elements of the CAML metadata and profiles, in order to describe the deployment layout of an existing application. They include the different cloud nodes and their cloud configurations, the application components and their concrete manifestations, and the cloud services they require. CAML defines a cloud metadata that describes the most relevant cloud entities for application providers, including cloud nodes, storage and services. Complementing the cloud metadata, CAML provides a set of profiles describing concrete cloud offerings, including Google App Engine. The Google App Engine profile defines Google's specific entities, such as instances, services, storage and the particular GUI configuration. From a deployment model for Petstore, we can generate deployment descriptors using the deployment tool. The user is prompted to select the cloud target. Upon a while, deployment descriptors configured from the Select Deployment model are generated within the deployment folder. The deployment of Petstore is laid into a couple of nodes, one hosting the Petstore web application and the another one its data storage. Therefore, corresponding GUI module deployment configurations have been created. Finally, the migrated application must be validated to ensure it keeps the functionality but also incorporate new features such as security, performance. Now we're going to show the model-based tester, which is aimed at checking the functional equivalence of two FUML models. FUML is a subset of UML consisting of the key parts of UML activities and classes. The first model contains the legacy Petstore. There we can have a look at all the classes, activities, operations, objects flows, control flows, etc., that compose this activity diagram. Same thing for the migrated Petstore, which we will also be loading. We have produced some activities that are the actual cases that will be tested. For example, we have the test login activity, which in turn is calling a login scenario activity, available in the model, by means of a call behavior action. With this activity we will test the correct execution when a user logs in. We have also the test find item activity, for testing that a previously stored item can be retrieved. This activity is also calling others available in the model, such as setup customers, setup items and setup services. These activities are present in both models, the legacy and migrated one, so we can check if they behave in the same way. We have also defined the functions to call the different assertions of the JUnit framework, both for the legacy and the migrated Petstores, and for the two activities defined before. The tests performed for both applications are the same, as we will show when we obtain the results. We can see how we are loading both models and the corresponding test scenarios. We now execute all the tests, where all of them are successfully passed. In the report produced, we can see the different tests that have been performed for each Petstore in each scenario. For instance, there are activities that check certain properties of the output obtained in the activity. There are also tests to check specific properties of the intermediate objects that are created within the activity. And also tests to check for associations among objects and attributes of objects. Now we're going to show the end-user-based testing, which is aimed at checking the behavioral equivalence of the migrated software and the original software. As an example, we take a SOAP web service migration scenario, from which both the original and the migrated service are running on two different servers. Furthermore, we assume that a trace model has been produced during the migration, that allows us to reason about the changes that have been made during the migration. In detail, we send a user request to the migrated service, through a monitor that uses this request and the migration trace model, to produce an equivalent request for the original web service and then compares the responses produced by both user requests. This source file contains our example. It specifies the details to reach both the original and the migrated web service and individual JUnit tests. First, we set up the monitor by specifying the location of the trace models. Then, we specify a modernized request which looks like that. In order to create a new pet category in the original system, we have to specify 4 values: category ID, category name, category description, and how many pets of this category are in stock. After having created the original request, we pass it to the monitor for execution. However, before we execute the request, we pass both the request and the migration trace model to a user request mapper for the purpose to map the modernized request to a corresponding original request. Then, we fire both requests to their respective applications and evaluate the responses by first transforming them to a platform-independent trace and compare them. So let's run this JUnit test. In the Package Explorer we can find the Create Pet category request and response that has been created or recorded earlier. Now, if we refresh the original directory we see that the execution created new files, namely the corresponding user requests for the original system. While the migrated user request requires the in-stock attribute to be set for the Create Pet category request, in the original system this was not the case. However, in the original system, to achieve this, an additional user request is issued. This, also automatically created user request contains the missing in-stock attribute. By looking in the JUnit tab or in the Console tab, we can see that the migrated user request has been successfully mapped to corresponding original user requests and that all three requests have been fired, validated, and compared. The final output line shows the test oracle returning pass, meaning that issuing these requests resulted in an equivalent behavior. Artist offers other additional tools to support the selection of best cloud provider for your type of application or for certifying the service providers. The benchmarking suite is an automated and multi-platform solution for the performance evaluation of cloud providers. 3alib is a library for measuring SLA-defined availability and detect SLA violations. Profiling is a tool to analyze application component computational behavior and extract runtime usage statistics. The certification model assesses the development of the SaaS application against best practices and industry-wide standards, from three perspectives: business, process and technology. Once artist process has been completed, Petstore is now an application fully compliant with the cloud offered as a service, and John passed from being a worried man to a confident one. More information about artist in our website. We will be pleasant to attend your questions and doubts. Find us also in social media. Thank you.